Hello, so today we are talking about y-intercepts. The y-intercept is the point at which a graph crosses the y-axis. So to show you what I mean, let me first highlight the y-axis. Remember, intercept just means to cross, almost like intersecting with something. So we're talking about where does the graph of these lines cross the y-axis? Well, let me just draw a dot right there. This one crosses it at that point, and the other one crosses it down here. And of course, we also know the coordinates of those points. This point is 0, 1. So we would say the y-intercept of this graph is 1. On my second line over here, the graph crosses the y-axis at 0, -5. So we would say the y-intercept is -5. Now, for some reason, we like to use the letter B to represent y-intercepts. So we could say B equals 1. We could say B equals -5. That's not hard, is it? One thing to be mindful of is to be sure you're looking at the y-axis. If you chose this point, for example, this is the x-intercept. That's a useful point, but it's not what we're looking for when we are looking at y-intercepts. And that's why I went ahead and highlighted the y-axis. What we want to look for is where our graph crosses the y-axis when we're looking for our y-intercepts. So highlighting that y-axis is a good strategy to help you be sure you've got the correct intercept. Okay, sorry, x-intercept. We'll use you later. Not in this lesson. So how about you give it a try? Find the y-intercept of these two graphs. It's okay, take your time. Good job, you probably got it. Okay, so we know that our first value is going to be 0. The x value is always 0 at the y-intercept. And on this next one, our y-coordinate is -1. 0, -1. That's our y-intercept. You may have written b equals -1. What about the other one? This one is exactly halfway between -4 and -5. In other words, it's at -4.5. So we could say b is equal to -4.5. And you know what? I didn't use my strategy of highlighting the y-axis. Let me do that. It's a good idea, and I want to model that. All right, there we go. Good job. Not so hard, right? So let's talk about what y-intercepts mean in the real world. They're actually really useful when you're talking about real world concepts. So for example, here we have a student who was working out and he had a goal. He wanted to work out for 50 minutes. Well, at the beginning of his workout, he had 100% of that workout left. At the end of his workout, he had 0% left. Let me highlight my y-axis. That's what this 100 up here means. It means that before he started working out, he still had 100% of the way to go. So B equals 100 tells us something about his goal and where he started. Check out this one. This is a student who is riding their bicycle to the recreation center. Can you tell how far away they were when they started? How far from the rec center did they start? See, y-intercepts really are useful because we can tell that they started 9 miles away. In fact, a lot of the time, your y-intercept will be your initial value or your starting value. So here's some different ways to think about it. The initial value, the starting value, the beginning value. A lot of the time in a real world context, the y-intercept is just telling us where we started. And that's the case here too. This is showing how much money an employee makes based on the number of hours they work. Well, they start at 0, right? If they work 0 hours, how much money do they make? $0. And that's why our y-intercept here is 0. Because if I work 0 hours, I get $0. You can also think about y-intercepts when you look at a table. Okay, so a table doesn't actually, it's not a graph, it doesn't cross the y-axis, right? There's not a y-axis on a table, but we can still figure out where that value would be if we were to graph these relationships. all we have to look is, where does x equal 0? If we can answer this question, where is x equal to 0, then we can find where the y-intercept of our graph would be if we were to graph the functions represented in these tables. So for example, on number 1, when the number of hours I work is 0, that's my y-intercept. So in this case, I get $20 if I work 0 hours. Maybe that's if I'm going out to repair somebody's house. Maybe there is a fee just to travel, just to show up. That's a pretty common practice. Let's look at the next one. This would be the y-intercept of this function if we were to graph it. Now, what about if we look at it sideways? Same story. Just remember that our convention is to have our x in the top row and our y in the bottom row. So that means this first one here, this is our y-intercept. So we start out with $32 in our account. And for our last example here, the y-intercept would occur at 0, 0. It would occur at the origin. When x is equal to 0, y is equal to 0 too. So when you're looking at a table, if you can find where x is equal to 0, you have found the y-intercept. That's where that graph would cross the y-axis if you were to plot it.